Hello, I am Kajal Sharma and today we are going to solve problem number 199 of LeetCode, that is from the tree data structure. It is a very simple problem and we have to print the right side view of the tree. So any tree could be given and we have to print the right side view. Let us first of all read the problem statement here. So given a binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. So we can take a quick example and can understand the problem statement. So this is a tree. So now consider these nodes which you can see like 1, 2, 3 and etc. to be a building, right? So what I'm saying is that this node is just a building, right? So 2 is also a building and 3 is also a building. Okay, and they are on a same level, right? This is a level, this is a level, and again this is also a level, and they are on the same level. Same level means same straight line, right? So they are on the same straight line. Now if a person will start from this particular level and he will be asked about what building can you just see, so he'll say I can see building number 1. Similarly, if he'll go to the second level and will be asked that which building can you see now, he'll say building number 3. He don't know if there's any other building beside 3. Why? Because if you'll see in a straight line and if a building of same height is present somewhere behind the building which you are seeing right now, you won't be knowing that there's a building beside or behind that particular building as well, right? So similarly, if he'll go to the next level, he'll say that only building number 7 is visible to me. At this particular level, he'll say building number 9, and of course here the answer would be 10. So the buildings that will be visible from the right side, if he's standing at the right side of each level, he'll say that I can see building number 1 at level 1, and 3 on level 2, 7 on the third level, 9th on next, and 10th at the end. So these are all the buildings which I can see level by level, right? So we were asked in the question to traverse from top to bottom. That is, we have to answer from top to bottom what all buildings can we see. So this can be a reverse question also. There could be a reverse question also. So there we will be answering it in just the opposite manner, right? But as we are asked about the simplest way, the top to bottom way, so we have to traverse from the first, second, third, fourth, and then the fifth level. So this was the basic problem. So we have to just print the rightmost element, the rightmost nodes, right, which are in the particular tree. Now we can start with solving this problem. So as you can see that we have to return a list, as the problem asks us to return the list of all the nodes that will be visible to a person standing at the right side, that are all the rightmost element in a particular level we have to answer. So for that purpose we'll first be initializing one, we'll be first declaring one list at the starting. Right, now we can check if the root is equals to null. That is, if some way the thing is that we are given only with the null element, so that could also be a case. So if this is the case, we can just return the empty list, right? So we can just return the list which is empty for sure right now. Next, what we can do is we can start up with a queue, right? So here we are declaring a queue. Now we can add the first element to the queue here. that is the root itself. And now we can start up with a loop that will just check for the condition if the queue is empty or not. Right. So now we will check that how many elements are present in the queue at a particular level. For that we are having this variable called n, and we are initializing it with the size of the queue. It will return the number of elements at a particular level, right? So how it is happening, we'll dry run the code with our example, and we'll see that how it is all working, right? So now I equals to 0, I less than the n, that is the size of the queue, and I plus plus. Now we can take one temporary variable and store the nodes inside it. So tree node. So type of the temp will be tree node. Why? Because we are going to store the nodes of type tree node inside it, right? This particular function, what it will do is that it will tell us that which element is present at the top right now or at the very front of the queue, and it will take out that element and will store it inside the temp, right? Now we can start off with the conditions. If I equals to 0, that is, it is the rightmost element of the queue, we can just add it to the list. That is list.add function can be called right now. We have to store the value only, of course not the whole node, right? Next condition could be if there is any right element or right child for this particular node we are traversing right now. So we'll check if it is equals to null or not. If it is not equals to null, of course, insert that element into the queue. So queue.add and temp.write. So here we inserted the rightmost element or the right child of a particular node. Again, the same thing for the left node as well. If there is any left child for a particular node, we can just add that into the queue. Afterwards, we can come out the while loop and we can just return the list at the end, because now it will be containing all the elements, all the values which can be visible from the right side of the tree. So now we can run the code. So it is accepted. Now we can just submit it. Okay, so it is submitted successfully. Now we'll try to dry run this code with our example tree, right? So we can just paste it over here. And let's try to check this with our example tree, right? So the very first thing is that we have to create an empty list, right? So let us create one empty list. So this is our empty list. The second thing it says is that if root equals to null, right? That is, this is the root and it is not equals to null, so this condition is itself is not satisfied. If this would be a case, that is, somebody would have passed something like this, then an empty list would have been returned. So this is not our case, so we do not have to worry about this case. Now we have to initialize one of the queue with the root element here, right? So let's make a queue. This is our empty queue, and here we are adding a root element. So node number 1 with the value 1 is added. So here whole node is added, not one value only, right? So whole node is added here. Now we have to check for the while condition if queue is empty or not, right? So of course the queue is not empty, so the while it, so we'll go inside the while loop, of course. So we check the condition if queue is empty or not, and we are given up with a false, right? So while it is true, while the statement itself is true, we can go inside the while loop and we can initialize one variable called n with queue dot size, that is whatever is the current size of the queue. The next thing would be to go inside the for loop, right? And the for here will run for I equals to 0 to I less than n. Here n is equals to 1, so for only one time the for loop is going to run, that is for the value 0, right? We have to have one temporary variable named as temp, which is going to store the frontmost element, that is node number 1. Now we are going to check the conditions if I equals to 0, which is correct for this particular node, that is I is equals to 0 here. So what we have to do is we have to add the element into the list, right? So this is added. Now we have to check if there is any right element, that is temp dot right is not equal to null. Of course it is not equal to null, so you can just add it to the queue, right? So this element is not null, so we can add it. Of course it is bold, so it is not present now inside the list. Now we have to check for the left element if it is there. Of course 2 is also present, so we can add it into the queue as well, right? Now for loop is terminated, the condition is not satisfied, right? So we have to check for again for the while condition, that is queue empty? Of course it is not empty. Now the value in turns has become 2, that is the size of queue is now 2, right? So the for loop here for the second condition, this for loop will run for 0 and 1, that is for 2 times. Then for 2 it will be, the condition will be not satisfied, that is 2 is less than 2 is not satisfied, so it will only run for 2 times. Here temporary variable will now store the frontmost element, that is 3, so temporary variable is now having 3 and it is taken out of the queue now, right? Now again for I equals to 0 we are inside the loop and we're checking for if the condition is satisfied, and of course it is satisfied, so we have to add the element to the list. The value is 3, so we'll add the 3 to the list, right? Now it will check if there is any right element, right child attached. Of course 7 is there, so what we can do is we can simply add 7 to the queue, right? And again we'll check if there is any left element. 6 is also there, so we'll insert 6 also from the rear end, right? Now for I equals to 1 we'll check this condition, so this is not satisfied, right? So we will not add any element to the list. We'll check if first of all we have taken out the node into the temp variable, so 2 is taken out and now is stored inside the temp. The value of I has become 1 this time, right? Now this condition is not satisfied, so no element will be added to the queue, sorry, will not be added to the list. Now the condition here is if there is any right element to the node, that is to the 2, yes of course 5 is there, so we can just insert 5 into the queue. Again for the left, of course left child is also present, so we can insert that particular node also inside the queue, right? So this loop has worked its way. Now we have come we are out of the for loop and we'll check for the while condition. So here we are asking for the queue if it is empty or not. Of course it is not empty. Now the size of the queue is in fact 4, so n is updated to 4, right? Of course. So now the for loop will work for 4 values, that is 0, 1, 2 and 3, right? So for I equals to 0 we entered here, and now the temp has become the first element inside the queue, that is 7. So now 7 has came out. Here I value is 0, so we'll check for the condition if I equals to 0. Of course it is. So we'll add this particular value to the list. We'll check if there is any right child or left child attached to 7. It is not there, so we'll not append any value to the queue as well. Now for I equals to 1, we'll go inside the loop. We'll change the temporary variable from 7 has come out, now 6 is also coming, so now 6 is here, and we'll check if I equals to 0 is satisfied. Of course not. If there is any right element, of course it is there, so we'll insert it inside the queue. If there is any left element, there is no child at the left, so that's it. We'll go inside the loop for I equals to 2. We'll take out 5 from the queue. We'll check for the condition I equals to 0 not satisfied. Is there any right element? No. Is there any left element attached? Yes. So we can just go and append 8 to the queue. Right. In the similar way, for I equals to 3, we'll enter the loop. For I equals to 3, 5 has been taken out. Now for I equals to 3, 4 will be taken out. Right. So now 4 is the element that is stored inside the queue. We'll be checking for any right or left element because this condition is not satisfied. So of course there are no more elements to be appended to the queue for this particular level. Now we have come out of the for loop. Now the condition I is less than n is not satisfied, so the for loop is terminated. Now the condition q is empty is checked, and of course it is not satisfied right now as well. So we'll go inside and update the size of n to 2. Now the for loop will work for two values, that is 0 and 1. For I equals to 0, 9 will be taken out of the queue. Right, so 9 will be taken out of the queue, and it will be checked if I equals to 0 for this particular temp value. Of course it is, so 9 will be given back to the list. Now is there any right element attached to it? No. Is there any left element? Of course yes, so we'll append it to the queue. Right. Similarly, for I equals to 1, 8 will be taken out, so 8 is taken out of the queue. Right, and again the condition will be checked. I equals to 0 not satisfied. Is there any right element? No, of course not. Left element? There is no left element as well. Now again the condition will be checked if the queue is empty or not. The queue is of course not empty because one element is still there, so now it will work for I equals to 0. Only for one value will enter the for loop, and now temp will store value number 10. Right, so now there is no element present inside the queue for sure. For I equals to 0, we'll check the condition if I equals to 0, and of course it is satisfied, so we'll add this particular element to the queue, to the list, and that's it. The for loop will be terminated now. Now the while condition will be checked for any elements, of course, if there are any element present inside the queue. Of course there are not, so now we can just come out of the while loop as well, right, and we can return the list from here. So the returned list here would be 1, 3, 7, 9 and 10. Right, this list is being returned as the type was here list, hence we had initialized the list and we were updating it right here every time, and we are returning that particular list now. So in our program this particular piece will be returned and will be printed onto the screens. So this was all about the problem number 199. Similarly, problem number 513 is also following the same logic, so it can be solved simply using this logic. It is just asking for the left view rather than the right view, so these two statements will be interchanged simply. So thank you.